And welcome, everybody. It is so good to have you for a few minutes today. Last week, we took a look in our live stream at some topics regarding, what did we talk about last week? Oh, yeah, OSPF routing, the link state routing protocol that converges quickly. I had a lot of fun. And I asked you last week what topic you'd like to cover this week, and the majority vote was Dhcp snooping. So that's exactly what we are going to do. Also, I wanted to ask this question as well to make sure I got your input for next week, and that's this. What topic would you like next week? And here's our three choices: switch port security, dynamic ARP inspection, or access control lists. And each week I'll promote or suggest 3 or 4 different ideas, and then I'll let you choose it. So if you take a moment right now and type in what you'd love to have for the topic next week, and we'll do that for the live stream. I also, before we talk about Dhcp snooping today, I want to thank you for your attendance and for being here with me. And I want to share something. Oh, it's a little embarrassing. So today was an interesting day. It's the day before Thanksgiving. And so I finished up my work earlier today, and my son and his girlfriend were down visiting, and I got chatting with them, went to have a nice lunch, and then I totally forgot about the live stream until about 2 hours ago. And then I realized Jake texted me and said, hey, do you want me to moderate your live stream today? And I said, oh my gosh, it's like that dream where like you forgot something or you didn't have the tools. My dream is this: I have a class or some type of a session and I can't get online, or I forgot it was going to happen. So about 2 hours ago, I was reminded that I had the live stream, and because my schedule a little wackadoodle, like, oh my gosh, I'm so grateful that I remembered. I don't want to miss a single session with us. Also, the new Ccna content and the DevNet content is being released in December. I'm going to say this month, but it's the 27th of November, so it'll be released in December. Looking forward to that. Also, in DevNet, they gave me a chance to teach network fundamentals in DevNet. So as we learn how to automate routers and switches and networks, it's important for a person to know what the devices do. So there's a entry-level section called Network Fundamentals in DevNet that I'm super excited to be part of. And I'm working on that course with Ben Finkel and Knox Hutchinson, who are in charge of walking us through setting up an environment for automation, the infrastructure, and then how to actually do the network automation. It's amazing. A lot of fun stuff. So all that content's coming out very, very shortly in December of 2019. So I'm looking forward to having you enjoy that. So getting to the point of today's topic, which is Dhcp snooping, let me bring up a screen and let me share with you the behind the scenes look at what we do when we create content here. And let me just line this up so we can see it here. So this is my CBT Nuggets. We use a thing called Studio, and this is the content I've created regarding Dhcp snooping. There's a quick introduction, and instead of playing the introduction for you, let me tell you about why Dhcp snooping is so darn important. DHCP, the Dynamic Host Configuration Protocol. It's sort of like the protocol that automatically gets devices an IP address so they can work on the network. Because really, to communicate on a network, we need a few things going for us. We need an IP address, which includes the network portion, host portion with a mask. We also need a default gateway, unless we just want to stay on the local network all day. We also need something to do name resolution. So when we go out to a site like www.abc.com or twitch.com or cbtnuggets.com, that needs to be resolved to an IP address, and so we use DNS for that, domain name system. And so every device, if it wants to use DNS, needs to know about the IP address of a DNS server. So we can configure that manually, and sometimes we do on our core network devices, but for most of the clients, thousands and thousands of clients on networks, we use DHCP, Dynamic Host Configuration Protocol. And it basically boils down to 4 exchanges, 4 packets. And let's you and I play the role of a DHCP client. It goes like this. Somebody goes to the computer and they click the radio button in network config that says obtain an IP address automatically, which means be a DHCP client. So for the client, we shout like this: hey, I'm looking for a DHCP server. It's a broadcast at layer 2. It's a broadcast frame that's being sent in that VLAN to all other devices. Now, if there's a DHCP server listening on the well-known port for DHCP, and DHCP also, by the way, at transport layer uses UDP, User Datagram Protocol. So the client shouts out, hey, I'm looking for a DHCP server. And if there's a DHCP server, the server responds with an offer. So the initial client request is called a discover, and then the server offers. Now the server, what's it going to offer? Well, if there's a DHCP server that offers, the DHCP server could offer us, hey, here's a beautiful IP address. You're going to love it. Here's the mask. Here's the DNS server you can use. Here's the default gateway you can use. And those are all included in the offer. Well, the client, us, we say, whoa, thank you very much. That looks great. I'll take it. That's a request. So the client says, I'd like to request the offer you just gave me. I'd like to request to have that IP address and use that information. And then the final acknowledgement from the DHCP server says, yep, you got it. That's the acknowledgement. So that process is known as DORA, D-O-R-A. Discover from the client, offer from the server, request from the client, acknowledgement from the server. Like Dora the Explorer. And that's a lot of fun. It's used millions of times every day across networks. And the challenge is this. Somebody brings in one of these from home. This is an example of a home type of wireless access point and router. And if somebody just takes this from their home and they bring it to work and they plug it in and they power it up, these bad boys have a DHCP server built in automatically. And they're handing out IP addresses, and very likely enough the correct IP addresses, the correct DNS information, the correct default gateway for the corporate network. So the poor client who does the discover and gets an offer from this guy is going to get bogus information. There's going to be a denial of service, a failure of service for that device. And it also could be more malicious, like this bad boy right here. Say hello. Oops. Say hello to my little friend. Now, many of you may recognize what this is. But this is a Raspberry Pi. Very inexpensive. This device has a USB ports, and this one has a wireless card, and it's got a slot for a hard drive, like a flash card, and a HDMI output, and an Ethernet connection. So basically, it's a computer in a very small form factor. It's powered by USB power. So a device like this, if it's plugged in, if it's running like Kali Linux software or even other software, it could be a DHCP server. And if there's an attacker on your network, the attacker may want to hand out bogus information or hand out itself as the default gateway. So clients, when they get an IP address, they use this device as the default gateway, and this guy can route then onto the real default gateway and act as a man-in-the-middle attack. So easy to do. So in the 90s, that's what happened accidentally. So in the 90s, when Wi-Fi was fairly new, fairly readily available, I went to a conference. And at that conference, I had my huge laptop. I mean, it's like massive brick. And it was running Windows NT 4.0. And they had these wireless network cards that you could rent to check out. So I put one in at the time. It was probably when WEP was like the thing. Anyway, I plugged it in. And I wondered, could I be a DHCP server? And the answer was yes. So there was very little security at all. And I created a scope of addresses that was appropriate. I pointed to myself as a DNS. This is like in the 90s. I pointed to myself as a DNS server, and then I had my DNS server use the real DNS server to look up. So I didn't actually manipulate or harm anybody's traffic. I didn't cause anybody's traffic to go to unauthorized or unintended websites. But it would have been super easy to do, and it still is. So a company or a person who's curious could either in software or with a dedicated device become a DHCP server, start handing out IP addresses, and unfortunately could cause a compromise on the network. So how do you prevent that? I'm glad you asked. The way we prevent it is we just tell the switch, like this guy. We just tell the switch with a technique called DHCP Snooping, no. What do you mean, no? Well, you know those messages that a DHCP server would send into the network? In fact, let's connect it up. So let's imagine that this is our rogue DHCP server. This is a plastic baggie that I will use later. That way I keep my cable straight. Speaking of straight through cables, This is a straight through cable, patch cable. So I plug in here, and imagine this goes to the switch port. And now this is a DHCP server, assuming it was powered on and had power. So if this is acting as a DHCP server, when a client issues a DHCP discover message, and this rogue, fake, mean DHCP server sees it and tries to respond, when this guy sends an offer into the network, a DHCP server type message into the network, the switch on this port, once DHCP snooping is running, the switch says, no, I'm not accepting any inbound ingress traffic regarding DHCP server type messages like offers, acknowledgments, things like that. I'm not allowing them in unless this is specifically a DHCP snooping trusted port. So by default, if we enable DHCP snooping on Vlan 10 and we didn't specify this port as a trusted port, anytime this device tries to send in offers, acknowledgments, anything that a server might respond into the network with, the switch at this port will deny it. This is a fantastic feature that how many people should be running this if they have the capability in their switches? Everybody, because we don't want to accidentally or maliciously have anybody acting as a DHCP server trying to deny traffic coming into our networks or trying to influence our networks. So I'm going to put these back in the baggies so I can sort it. I also learned a long time ago that by putting my stuff in so this is a bin called Ethernet. So, and I've got like 6 bins of various types of devices and things. By keeping them in bags, it helps them not to get tangled as much. So this is an adapter that goes from a straight through cable to make it a crossover cable, which is fantastic if you need it in a pinch. And I've got fiber with various connectors. So anything related to Ethernet and Ethernet cabling and connections, I keep in this bin right here. And I'll tell you what, it comes in handy. So I've got one for power circuits, I've got one for network devices, power cables, audio devices, USB, and it makes it really handy. Okay, so that's the scoop regarding DHCP snooping. So what I like to do is I'd like to play you I think I might do is just show you one video that talks about the basics here of how it's configured, because we just talked about why it's needed. Talk about here why it's needed, and then maybe walk you through a lab where I provide a hands-on lab for actually implementing and verifying it. So before I launch the video, the recipe for DHCP snooping, which is basically the ingredients of how to get it done, I'd like to go ahead and give you a moment. If you have any questions about what we have talked about so far regarding DHCP snooping, go ahead and type it in. Jake's helping me on the moderation, and we'll give that a few 15, 20 seconds for any questions to make sure I've got them. And without any further questions, we'll go ahead and watch the video. So I'll be right back, and thanks in advance for your questions. Okay, and I do have one question, and then we'll go straight to the video, and that's this. Hey Keith, I'm getting my A+ by the end of the year. Fantastic, way to go, awesome, awesome. And I'm just looking at my notes. Thanks, Jake, for feeding these to me. And after that, after A+, should I do Network Plus or the new CCNA after A+? I am so glad you asked. Here's what I would do. The Network Plus is amazing, the CompTIA Network Plus. It covers a lot of ground, a lot of fundamentals. And if I was going to do it and I was going to finish my A+ by the end of this year, I would go right into Network Plus, study that for a couple months, 3 months, ramp up on it, make sure you're comfortable with it, go take that exam. Because then immediately following that, and maybe it'll be February or March, because the exam will be then out then as well, maybe even April, if it takes you that long to finish Network Plus. When you go into CCNA, most of that content that you've learned in Network Plus you will be able to directly apply to the world of CCNA. Because I would do the A plus by the end of the year. That's fantastic. Then Network Plus, and then right into CCNA, because by then it'll be available. And let me read it out. It says, do I think Eve? Okay, so I believe the question is about EVE-NG and GNS3 and getting hands-on practice. So here's the key for hands-on practice for CCNA. You ready? The goal is to get the hands-on practice. And there seems to be a feeling of, oh, I got to have the physical gear. And I've got to have the physical gear right next to me and touch it and put the cables in. In the production environment, we rarely see the physical gear anymore. I mean, you can walk to the data center and you can see the physical gear, but most of the time we're in our office, at a desk, at a site, working on devices that are physically not next to us. So in the real world, we're going to be working in terminals and looking at topology diagrams and configuring devices, but not a ton of consoling in and doing it right there on the physical gear. So as far as hands-on practice, my number one recommendation would be, if you're a CBT Nuggets customer, please use our virtual labs, because just like what I'm going to show you here in just a few moments, we're going to walk you through how to configure it and then give you hands-on practice to do the actual configuration. So that's pretty easy. It's a click. We try to reduce the friction between learning it and practicing it, getting hands-on. So if you're a CBT Nuggets customer, launch the virtual labs wherever they exist, because that'll help you a lot. I'd say the second most easiest way to get hands-on practice is Packet Tracer. So I've got a skill. In fact, let me show you. I forgot. Hey, I'm here in studio. I can just show you. Let me go to dashboard and go to Control F and look for PACKT. Here we go. So I did a set of videos, and here they are. They are 9 videos, and they walk you through from soup to dessert how to set up Packet Tracer, how to use it. And most people, I'll bring back the video here. Most people, when I show them Packet Tracer, their jaw drops. It's like, what? You can build a rack of equipment. Yeah, you can either choose the devices and build a rack of equipment virtually and then go to the logical topology, or you can build a logical topology and then look at the rack of equipment and then use the commands. And at the CCNA level, it's all you need. In fact, it's more than what you need as far as the hands-on practice. And it's so easy, and it's free. You go to Netacad, sign up for a free account, download the legal version of Packet Tracer, install it, and start using it. And it doesn't cost a dime, and it's fantastic practice, especially for the CCNA level. So, so for the CCNA level, the hands-on labs at CBT Nuggets are great. The Packet Tracer is super easy and readily available. I strongly recommend it. Physical gear, if you want to buy some used gear, if you have the time and money for that, great. That's what I did back in 2000. Let's see here. back when I was a kid in 1990, I guess it was 1999, getting ready for my CCIA, I bought physical gear. And it was very expensive back then, but I bought the physical gear, put it together, and it was all I had. It was the only option I had. Additional options that exist are Viral, VIRL. That's a licensed Cisco product from Cisco. It's like, I think as the time of this recording, probably at $200 a year for a license. But to install it, it takes a little bit getting going, but you install it, and you can do just tons and tons of high-end devices, including Nexus and so forth, right there in Viral. So that's another great option. So as far as EVE-NG and GNS3, I would say that for just hands-on practice for CCNA, you might want to skip the pain and just go right to Packet Tracer and the labs at CBT Nuggets and just call it good. And then when you get onto the advanced topics, professional level and CCA level, and you need a little bit more, Viral and other tools like that would be very, very helpful. All right, so hopefully I answered that for you. And all right, then there's one other question. It's asking, does it work the same way in IPv6? I see. It, meaning DHCP snooping. That's a great question. So for IPv6 and DHCP, because there's the automatic configuration for IPv6, where clients don't actually need a DHCP server to dynamically get an IP address, there's router advertisements. And the router's advertising the network prefix, and then the IPv6 client will say, oh, I'm going to go ahead and create my own host address, and then I'll make sure it's not a duplicate. And so as far as protecting it, is that DHCP snooping, I don't think would be the appropriate tool for that. What we'd want to protect there is the router advertisements to make sure that no rogue device is lying or advertising about what the network is. So it would not be DHCP snooping as a security tool for that. And for the life of me, I don't know what the right tool would be. But an IPv6 would be protecting against the IPv6 router advertisements from a bogus or untrusted router that injected itself on the network and was trying to lie. That's a good question. I'm going to look into that. All right. So I think that's all the questions in the queue. Thanks for those. And let's do this. Let's go to the interface here. And let me go back to snooping. SNOOP, Snoop Dogg Dog. Okay, here we go. It's the shizzle. All right, videos. And let's do the recipe for DHCP snooping. That way you can see the commands that are used for making it work. And then we'll go right to the apply it in the production environment. My voice is getting a little hoarse. Not sure why that is. All right, so I'm going to put it at 1x speed. I'll put it at the beginning. Let me look at my second monitor here and make sure I can line this up. And enjoy. We'll be back in just a few moments after this is done, and we'll take some questions and we'll queue up the second video.
In this video, I'd like to chat with you about a few of the ingredients and commands that you and I are going to use to implement DHCP snooping, and also reinforce where in our enterprise we're going to implement this feature. So let's consider where a rogue or malicious DHCP server might be injected, and it's very likely can be injected where users can connect to the network, and that's the access layer. So if we have access layer switches with wiring that goes over to the offices and cubes, it's really here at the access layer and the access layer switches where we want to implement the feature of DHCP snooping. So let's imagine that for this network up here, let's say this is Vlan 30 that's being supported up here, and these are trunks going down to the core and distribution layer. Let's imagine our DHCP server is right here, our legitimate one. So to implement DHCP snooping on this access layer switch, here's the command we'd use. We'd use the command IP, DHCP, put my little spaces in there, snooping, enter, boom. Now that enables DHCP snooping the feature on the switch, but it doesn't apply the feature to this VLAN. So we need to add one more command, that is IP, space, DHCP, space, snooping, space, VLAN, space, and then if it's VLAN 30, we'd put a 30 right there. So now with this 1-2 punch, the feature is enabled and it's applied to VLAN 30. So with this in place, let's consider this machine right here. We'll call it PC 1, 2, 3, 4, 5, PC 5. It boots up, it's a DHCP client, it does a DHCP discover message. So in the discover message, it's going to send out a frame, a broadcast frame, and for the source layer 2 address, it's going to use its MAC address, and then inside the DHCP message, the discover message, it's going to include its layer 2 address. If those two MAC addresses, the one that's in the layer 2 header and the one that's in the DHCP discover message itself, if those are not the same, this port right here says, I'm not letting that go in. It's not congruent. Something funny is going on. And that's because all the ports in this VLAN, VLAN 30 by default, are considered untrusted. And so there's some extra inspections that are going to go on as a result of that. Also, if Bob or somebody else plugs into an access port here and they have a DHCP server, meaning they have a device that's trying to do DHCP offer messages or acknowledgement messages, if the switch with DHCP snooping sees any of those server type DHCP messages trying to enter the network on a non-trusted or untrusted DHCP snooping port, it's going to drop those. And that way we're protecting our network from having unauthorized DHCP servers added or connected to our network. So if this client does a discover message and that discover is broadcast and it's forwarded down the trunk and this DHCP server sees it, my question is, what's a really good DHCP server going to do if it gets a discover message? Well, you might be saying, well, Keith, it's going to respond with an offer. Exactly. And that's where the problem comes in if we have DHCP snooping enabled for the entire VLAN. Check this out. When the server responds with the offer saying, hey, I've got a beautiful IP address, you're going to love it, and it tries to send it into the switch, It goes in here to core 2 because core 2 does not have DHCP snooping enabled. That gets forwarded up the trunk and up to the access layer switch. But right here on this trunk port, guess what? DHCP snooping is enabled for VLAN 30. So that's tagged VLAN 30. It's a DHCP offer coming in, and the access switch says untrusted port and kills it, which is not the intent. So what we'd also want to do is we'd also want to specify from the access layer switch's perspective which ports are to be trusted, meaning which ports lead to legitimate DHCP servers. So on the access layer switch, if this is port 0/1 that goes down to core 1 and 0/2 that goes down to core 2, we'd want to configure both of those trunk ports as being trusted, IP DHCP snooping trusted ports. And the syntax to do that would be to go into interface configuration mode for these two trunk interfaces on the access layer switch, and we'd use the command IP DHCP snooping, I'll put a snoop for short, space, trust. And if we did that for each of these two trunk ports, that would make them trusted ports, and as a result, when the DHCP server sends its offer and its acknowledgments and messages from the server back up into that access layer switch, the access layer switch will allow it because it's coming in on a trusted port. So in this example, all of the access ports would be untrusted from a DHCP snooping perspective, and the trunk ports would both be configured as trusted ports. And there's one more element that often causes DHCP snooping to be so good at what it doesn't allow any DHCP services to work, and that is option 82. In many networks, there's DHCP relay agents that listen for DHCP discovers on a given broadcast network, and then they unicast that, or they route it over to the DHCP server. Well, option 82 includes information about that DHCP relay agent. If we're using DHCP snooping, it can add that option 82 information as part of the DHCP request. We don't need that added information. In fact, if we add that information, it might cause DHCP services not to function correctly. So this command right here, no IP DHCP snooping information option, says don't, please don't include the option 82 information to the DHCP messages. And sometimes if that information is left on and DHCP snooping injects it, it causes DHCP services to fail. So please be aware of that command as well. In our next video, join me as we take a look at building a small network where we can implement DHCP snooping and verify its results. So I'll see you there in just a few moments. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.
All right, so those are the ingredients, and then I'd like to skip down to video 6, which is where we're going to apply. So also, there's other pieces and parts that I teach along the way, but applying DHCP to the production network is a good example of end-to-end. Also, check this out. So when I'm creating these videos and having a lot of fun doing it, I imagine that I'm talking like I am right now to you, and sometimes it doesn't go right. There's a mistake or a problem like, facepalm, I can't believe I just did that or whatever. So I'd like you to look out for, in this video, a couple challenges that I faced where I made a little slip up. And I thought to myself as I went through it, here's the verification commands, there's the problem. And I left it in because I thought, I want you, as we're going through this together, to realize that it's important to verify our work, make changes, verify the results, correct as needed. And I wanted to leave it in. It only took maybe an extra minute and a half, because I wanted you to see the logic and troubleshooting of going through it. So also in this one, I also did this. I'm trying to recall. This was I created this back in September, so it's been a couple months. But I believe this one also, I also set up a DHCP server on a Cisco router so that you can see that process as well. So I thought it'd be great to see end-to-end, and that way a student can replicate this or log into our labs and actually do it. So thanks for listening to me ramble for a minute there as I remember the details of this. I'm excited to see it too. It's been a while. All right, let's go back to the video and let's take a look at implementing DHCP snooping with this video, which is about 12 minutes in length.
It is that time, my friend. And you might be saying, Keith, what time is it? It's time to take the skills that we've been building and learning regarding IP DHCP snooping and apply it to the production network. So let's go meet with Bob. We'll take a look at the topology, what he has in mind. We'll make a plan, we'll implement it, and verify it together. Let's begin. it's a Tuesday morning. We walk into Bob's office, we exchange greetings, we say hello, and then we settle down and he shares with us the topology for the production network, which is this bad boy right here. And we ask him, okay, Bob, what do you want us to do regarding DHCP snooping? Where do you want it? And he says this, well, I've got a little work to do and it's all down here in Florida. We made a decision, says Bob, that instead of doing a DHCP relay on this interface and then sending the DHCP request up to a corporate server in Arizona, instead we just want this router, router 3, to act as a DHCP server to support VLAN 30. So VLAN 30 is this bad boy right here, 10.16.20.0 with the 24-bit mask. And Bob also indicates that router 3 is already directly connected to VLAN 30 and that subnet. So all we need to do is add DHCP services on there. But to help protect the Florida network from rogue DHCP servers, he would like us to configure DHCP snooping on this Florida switch to support VLAN 30 so that no unauthorized DHCP servers can just plug in and start offering IP addresses in who knows what subnet. In addition, because the DHCP server is directly connected to this network, Bob would like us to disable option 82 insertion for DHCP snooping. No problem, we did that in the previous video. We'll do it again here with the command no IP DHCP snooping information option. Then they'd like us to test it by going to this Florida PC, making it a DHCP client and verifying that it gets an IP address, and also going back to the switch to make sure we can look at the DHCP snooping information to verify that the switch has learned that IP address that this client's using along with its MAC address. Now, one thing that we definitely want to do is once we configure DHCP snooping, we want to specify that interface 3/3 is a trusted port because the DHCP server is off of that port. So in our troubleshooting, if the client is unable to get an IP address, either we didn't disable option 82 or we didn't make port 33 a trusted port. Either way, we'd want to make sure we check both of those elements and get full functionality from the Florida PC in getting a valid IP address and being able to communicate on the network. And because this is a virtual lab, you can click on the link. If you're logged on to CBC Nuggets, click on the link for the virtual lab, and let's walk through this together. So here on DC Nug, our management PC, let's open up MT Putty, upper left-hand corner, and we'll open up connections to, we'll need router 3 in Florida, and we'll also need the Florida switch, FL switch, great, and also PC1 in Florida. So we'll have those 3 tabs open. So let's start on the router and let's set up DHCP services. So to do that, we'll go into configuration mode, IP DHCP pool, and let's go ahead and call this our pool for DHCP. And the network, let's take a look at the plan again. So we're supporting VLAN 30, which is this network right here in Florida, 10.16.20.0. And this router is going to be .7. So I'm going to put a little .7 there. And we can set up ourselves, the router, as the default gateway at 10.16.20.7. So our pool will be 10.16.20 with a 24-bit mask. And we can also do excluded IP addresses if we want to. So back at the CLI, our network statement is going to be for the 10.16.20.0. We'll do a space /24, enter. And then for the default gateway, it's going to be the router itself at 10. You know what we should do? We should verify that this router has the IP address of .7. Always verify on new gear, verify what the current status is before we start making changes. We'll do a do, show, IP interface brief, enter. So sure enough, here on the subinterface .30, we have the IP address of 10.16.20.7. So that is the appropriate address to hand out as a default gateway. So we'll use the command default-router, and then that IP address, which I will just copy paste, making sure I don't do a typo. There we go, enter. And if we want to do a DNS server, we can hand out maybe Google, or if we have an internal one, we can hand out that as well and press enter. Great, and then we'll do exit. And let's also set up the first maybe 10 IP addresses as exclusions. So we'll do an IP DHCP excluded address, and then we'll do 10.16.20.1 as the first in the range, and we'll go through 10.16.20. Let's go through 10. So it won't hand those out. And let's do a show IP DHCP, and let's just go ahead and use the word pool, and that'll show us our pool. So fantastic. There's our range for the network, and we've also got 10 IP addresses that are excluded, which is .1 through .10. Great. So that's the router. Let's go over to the switch and set up DHCP snooping. So here on the switch, we'll do a show IP DHCP snooping, just to verify what we're starting with. The The snooping is disabled by default, and it's not configured for any VLAN, so we are good to go. So we'll go into configuration mode, IP, DHCP, snooping. We'll enable the feature. Next, we'll hit the up arrow key, enable it for VLAN 1, enter. And let's do a do show IP DHCP snooping. And so currently it's enabled. It's enabled for VLAN 1, and the insertion of option 82 is enabled. Let's fix that as well with a no IP DHCP snooping information option. Press enter, and we'll hit the up arrow key a couple times and do the show IP DHCP snooping again, just to verify that it is not inserting option 82. Great. Okay, so we've got the DHCP services set up on R3. We've got DHCP snooping set up on the Florida switch. But what we don't have yet is we don't have set up this port 3/3 identified as a trusted port that will allow the DHCP services to do offers and acknowledgements and server type messages back into the network. So let's also specify interface 3/3 on the switch as a DHCP snooping trusted port. So back on the Florida switch, we'll go into interface gig 3/3. And also we should do this. How do we know, for reals, that gig 3/3 on the switch really is connecting over to the router? How do we know? We're not physically there. Most of the work we do is in the cloud or in data centers. How do we know? And one answer is CDP. Because they're both Cisco devices, we can do a show CDP neighbor and just verify that it's the router hanging off 3/3 to make. So it's still in interface configuration mode for gig 3/3. And it's a good option, by the way. If you're not sure which interface you're in, you can always just go interface gig 3/3 again and confirm you're in the right place. And so here we want to do a bigger picture that if we had this switch configured with DHCP snooping, and if our DHCP services were down here somewhere, we would definitely want to configure on this access layer switch port 0/1 and 0/2 as trusted ports. Otherwise, when DHCP servers try to respond with offers and other things, those responses will not be allowed into the switch if these two ports are not trusted. So that's a key element. So whether the port is a trunk port or an access port, if it leads towards the legitimate authorized DHCP server, that port needs to be a DHCP snooping trusted port. All right, so here on the switch we've done our work. Let's go to our client. So this is the Florida PC. If we do a show IP, this is just a virtual PC. So show IP will show the IP address. So it's currently 10.16.20.30, and the default gateway is 10.16.20.7. But if we configure it to be a DHCP client, we would do this, IP space DHCP, and press enter. And one of the cool things about this, it shows us the DORA process. So it sent 2 discover packets, it looks like. Then they got an offer from the server, then it had a request, and the final acknowledgement, and check that out, it got an IP address. And the reason that worked was because we have DHCP services set up, and DHCP snooping is not prohibiting that server from responding to us. And we can go back to the switch, and let's do that now, and let's do a show IP DHCP snooping, and we'll let's tag on binding, and that'll show us what DHCP snooping has learned from its snooping. And I was literally expecting to see the entry there for the DHCP client. Let's do this. Let's do show IP DHCP snooping just to make sure everything's set. So it's enabled. Great. Oh. I'm so embarrassed. So in our previous exercise, we had enabled DHCP snooping for VLAN 1, and so I carried that forward here. So yeah, it's enabled on VLAN 1, but this client is in VLAN 30. So what we also need to do is enable this for VLAN 30. So that's the benefit of checking our work. So config T, IP, DHCP, snooping, and we want to do VLAN 30. Boom, just like that. I'm glad we checked. And we'll do a show IP, DHCP snooping, and verify. There we go. So we got VLAN 1, which we don't really care about too much, and VLAN 30, which is where our client is. So now let's go back to our client. So let's give it an IP address again. We'll go back to static IP, and then I'm just going to copy paste this bad boy right here. Boom. Just for a moment. And then we'll do a IP DHCP again to be a DHCP client. It's going to go through the DORA process, discover offer request acknowledgement, and survey says, boom, got 11. Now, if DHCP snooping is working and we configured it correctly, we should have an entry. If we do a show IP DHCP snooping binding, that should show that IP address that was just given to the PC along with its associated layer 2 address. And that should show up on the switch that's doing DHCP snooping for VLAN 30. Let's take a look. So back at the switch, we'll go ahead and hit the up arrow key a few times and do a show IP DHCP snooping binding. Press enter. So here's the IP address that was handed out via DHCP. There's the corresponding layer 2 address. The way it got into the table was via DHCP snooping. It was on VLAN 30, and it was learned on gig 0/1. That's where this client, PC1, is connected to on this switch. And in this video, we've had the opportunity to take our skills and knowledge regarding how DHCP snooping works, to apply it to our production network, and then also to verify it. And as part of the verification process, we identified that I had put in the wrong VLAN, and as a result, there was no entry in the binding table for DHCP snooping. That's why it's always a great idea to, when we configure something, verify it, make sure it works. And if it didn't come out like we thought, investigate the root causes and correct those, which we did. So I've had a lot of fun in this. Now, at the end of each of these sets of videos and each of these skills, my intention is we apply these skills to a production environment. If you've done this with me, if you've done it in an emulator, a simulator, on your own, physical gear, or in the labs, I would like you to give yourself 10 more points. And the goal being, let's get 100 points to represent growth and building skills and having fun and becoming more valuable to ourselves and our families and our employers as we become better and better in working with IP networks. So I've had a blast in this set of videos, and I look forward to seeing you in the next. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.
I'm having a good time. I am so glad you're joining me for these. It's a lot of fun because a couple of things, we get to identify what technologies exist that we can use to secure our networks, and then walk through together how to implement them and verify them. And the fun thing is this: in a production network, when we're actually implementing techniques like DHCP snooping, it's fantastic because we're protecting against rogue or even innocent people bringing those devices on the network and causing denial for other devices. So thanks for joining me for those. I appreciate it. I had a couple questions I wanted to follow up on. One question was asking regarding DHCP snooping, like why just access layer? Why couldn't we put it in the core? Could you put it in the core or the distribution layer? We could, but most of the time, users, those users, they've got access in their offices and cubes and through RJ45 connections, and those are connecting to access layer switches. So the most likely place for someone to attach to the network is at the access layer. So you certainly could have it elsewhere, but mostly it's at the access layer to protect against people where they do connect. Just remember your trusted ports, though. That bites me almost every time because without looking at okay, what are all the possible paths to the DHCP server? Because we could have a DHCP server that's hanging off the core or the distribution layer, and then we have to identify the paths, and not just the path that's being used, but also the path that spanning tree might use if there's a failure in the network. So a spanning tree, we've got the one path that we're using for forwarding layer 2, one path that's blocking. Well, if we only make the path that's forwarding a trusted port, and then there's a failure and spanning tree swaps over to the other path, and it's not a trusted port, our network just broke. So just consider any possible paths that lead to the real DHCP server as trusted ports. All right, so another statement was, I've got a router and a switch. He provides the models. I put the commands in on the switch, and it didn't work, including the no option A2. The switch is blocking the discover offer request acknowledge. The router is the DHCP server. I even added a helper address. What do I do? Well, after watching this, and you've done all those steps, here's what I would do. I would say to my device, let's imagine this is the router for a moment. Dear Mr. Router, thank you so much for being a DHCP server. I'm going to test you directly with a client. Just remove the switch from the equation. So you can take a crossover cable, go from the router directly to your PC in your lab environment, and verify DHCP is working. Now, if that works, you could also, with the switch in place, you could have your router connected to the switch, your client connected to the switch, and turn off DHCP snooping altogether and verify that that works. So if that's the case, where the router is the DHCP server, there's a switch in between your client and the router, and no DHCP snooping is enabled, and it works, and then you enable DHCP snooping and it stops working, I would take a strong look at trusted ports, like make sure that the switch on its connection to the router make sure that port that it's connected to, let's imagine it's, I put my cables away. There we go. All right, thanks. Oh, by the way, I get a lot of questions. Hey, your hair always looks different. How do you do that? Canned air. It's fantastic. You know, just get yourself going in the morning. All right. That's not literally what I do every morning, but sometimes. Okay, so let's imagine this is the switch, and it's going to the router. Let's imagine this is the router, and the switch is the second device. I'm going to have this device play our switch. Our switch today is played by a Palo Alto firewall. I've also got a Cisco firewall right there if that makes it feel better. All right. So router to switch. And what you want to do on the switch is you'd want to say that this port that leads to the router is a DHCP snooping trusted port. Otherwise, the server, if it's issuing DHCP offers and acknowledgments and so forth, the switch port, by default, DHCP snooping says they're all untrusted from a DHCP snooping perspective. It's not going to allow your DHCP messages to come in. So, okay, so the whole soup to dessert is try it without DHCP snooping if it works, and then you enable DHCP snooping. If it doesn't work, make sure this port on the switch that leads to the router, make sure that port is a trusted DHCP snooping port like we had in the video. If that doesn't work, there is an option that I recall. The DHCP information option or DHCP relay trust. I'd have to look it up. I do remember a few corner cases where I had to do a few additional tweaks. Now, the lab we did here was all the gear that is shown and all the commands that I used to make that all work. So in my CCIE days, I used to do a lot of CCIE labs, and we'd have tricky scenarios and make things break so people, the CCIE candidate would have to troubleshoot it and figure out how to make it work, and make almost near impossible scenarios so they could, get final functionality. But I'll tell you what, if you post that, I think it was Jonathan, whoever it was, when this video gets posted live, if you post that scenario again, if you're still having problems with that, I'll research it. I'll find the additional option or options regarding trust that may have to be done on the router acting as a DHCP server to make it function. But in the lab, everything that I just did was what you saw was how it worked. And there could be slight variations based on the version of iOS. So if you're interested in that, I'd be happy to help. Okay, let's see what else. And, InfoSec Pat said, during your demonstration, Keith, you enabled DHCP snooping for VLAN 1, and the client was in VLAN 30. Now, why is that so darn important? Well, to make it work, first of all, to have that protection. Also, the DHCP snooping binding table that associates the IP address and the layer 2 address that's learned through the DHCP snooping process, we're going to use that next week. Next week, we're going to take a look at dynamic ARP inspection to make sure that devices, when they connect to the network, they don't lie about what their layer 2 address is. It's a fantastic and easy way to do man-in-the-middle attacks is by I lie to everybody. I lie to this device. I say, hey, this is device A, this is device C, I'm device B. I tell device A that device C's layer 2 address is me, and I tell device C that layer A's layer 2 address is me, and they start forwarding frames to me when they want to talk to each other. Now I'm a man-in-the-middle attack. So that can be done by ARP spoofing, address resolution protocol spoofing. And that can be fixed or solved with a feature called dynamic ARP inspection, or DAI, which by votes earlier today, that's our next topic. So we'll cover that in more detail about what it is, why it's needed, how to implement it, how to verify it in our next session. Okay. There was another question I thought about Python. Maybe it went away. Regarding Python is a very friendly language. So for network automation, there's a lot of Python that's used. If you are interested in Python, the DevNet is a great starting point for a lot of people who want to get into automation. Also, Ccna has a section on network programming and network automation. There's a book. What's that book called? It's called I I think it's called Programming All the Boring Things with Python. And Knox Hutchinson, I'll tell you what you can do. If you want to search for Knox Hutchinson on YouTube, he just put a video on that today. And he talked about this book. And basically it's meant to be read over 30 days during your lunch, like 40 to 50 minutes a day for 30 days to get up and running with Python. And so if you search for Knox Hutchinson, I'll add it as a comment as well to this video in the notes. That's a great book to start. And in CCNA, we talk about some of the high-level basics, high-level ideas about network automation. And in DevNet, it's 3 major sections. In DevNet, there's network fundamentals, which I get to do, layer 2 switching, layer 3 routing, the TCP/IP protocol stack, how it works. It's great stuff. And then Ben Finkel talks about the infrastructure and the tools that we would use for network programming and development and network automation, the infrastructure to make it all work. And then Knox focuses primarily on doing it, how to do the automation, where Python fits in. So there's some basic training there. We also have some Python options at CVT Nuggets. But that book, which by the way, Knox has inspired me. I'm working on this project with Ben Finkel and Knox Hutchinson, and those guys are really amazing. And they're both way beyond me as far as coding and programming, including Python and apps that they work with for automation. And so after a little soul searching, I thought to myself, I'm always, learning new things. I always enjoy learning things. I thought I'm going to spend a couple months and go through our own DevNet content, including that book that Knox recommended about programming all the boring things with Python. And I'm just going to take it easy. I'm not going to try to cram it all overnight. I'm going to enjoy it. I mean, I understand the basics of Python, but I'm going to start applying it and learning it and using it. I mean, I've configured how many Cisco switches and routers and firewalls and intrusion prevention systems and load balancers have I configured over my lifetime? Just lots and lots and lots. And I thought it's going to be fun because Knox is in the DevNet. He's going to walk us through. He already has. It's just waiting to be released in December. How to use automation to do those things that we've done so repetitively. Like how do you query 50 devices and find out the certain values? Or how do you push elements to those 50 devices using scripts that use the commands that we know and love on those devices, but just doing it in an automated way. So anyway, I'm committed to doing that. And again, not as I've got to do this today. No, I'm going to enjoy it. I'm going to take the next 2 months and enjoy it. Spend maybe 45 minutes to an hour a day enjoying the videos at CVT Nuggets that from Knox and from Ben, and enjoying doing the hands-on practice and enjoy doing what they ask me to do and enjoy some reading just to increase my skills. Now, do I need to for my own personal, my career? I could probably get away without doing it, but when's the last time you got a really good skill where at the end of it you thought, I wouldn't want that skill again. Totally worth it. Like networking, totally worth it. So anyway, that's my own personal motivation to learn more about Python and getting more involved with it. Okay. One other comment from Jay Coley. I'm currently working for a major service provider specializing in SD-WAN. Awesome. I'm 53 years old. My brother. I was born in 64, so if anyone wants to do the math on that, we were very close. And have not taken a Cisco certs. Do you think it's viable for me to go all the way to CCIE at my age? That's a great question. But we all come from different experiences and different backgrounds, and we have different levels of abilities when it comes to taking tests and things like that. I think what I would do, I've been reading a book. You read, Keith? Yeah, I read. I've been reading a book. In fact, I've read it 2 or 3 times over the last year and a half. It was recommended to me by Dan Charbonneau, who is the visionary at CVT Nuggets and also the owner. And it's called Atomic Habits. It's a game changer. And Atomic Habits is all about not focusing on the prize at the top of the mountain, although it's important to have an awareness of where we're going, which ladder we're climbing. If we're climbing a ladder, make sure it's leaning against the right building, right? So we want to make sure it's leaning against the right building. But the secret is, in Atomic Habits, is he talks about who wants to win the Super Bowl. I mean, what football team wants to win the Super Bowl? All of them, all the professional teams. I want to, but who wins? It's not going to be everybody. So the secret is, he says, is to get better systems in place, better systems at improving ourselves. Like, I'm going for 10% body fat by May or June of 2000. When we have a trainer palooza meeting every year in Eugene, Oregon. We all the trainers together, and it's just great. So we get to connect and physically see each other as opposed to just virtually see each other. And last year I committed to getting to 15% body fat. And I had some help. I had a lot of good people coaching me and motivating me. I committed publicly. And I focused on the system, which is eating a little better, working out a little more smart, working out. How about that? And it's just science at that point. If you work out a little more, exercise a little more, and you eat a little better, and you keep on that going, keep those systems, then I'd have days. I'm going for days that I'm winning, not just, I've got to my goal, day by day by day. And so the same thing is true with working for a service provider or maybe thinking about a CCIE someday. I would focus on getting better at those things that you want to get better on and setting up systems. Like this week, did I get better? I use a journal. Here it is. And in it every day, it has a little rubber band so I can put my spot in there and find it. I specify what I want to work on and what examples. Today's top 3 goals. What absolutely must be done today. What are some things that it has a whole bunch of ideas to get me thinking. And then I just try to make every day a win. A win for me is a gold star. It's like, okay, Keith, did you do your cardio for 30 minutes today? Yeah. Gold star. Did you study that Python like you told people you were going to? You made a commitment publicly, like right here, you and I, that you're going to study Python over the next couple months just to have a better understanding of it, just to kind of enjoy some network automation. Even if I don't code for a living, it'd be nice. Because when we talk to the development team or the programmers, and they are starting to do automation for network devices, whether they're firewalls or firepower threat defense appliances or ASAs or routers or switches, whatever, they probably are going to want some information from us. And it'd be nice if we could have a common language. We could talk with them. So they could show us the script. We could take a look. We'll look at the Cisco related commands and have some mutual benefits there. So going back to the CCIE, I think anything's possible if a person is willing to put enough time and effort and concern into doing a thing. I think the question would be, if we're over 50, would be certainly it can be done. The question would be, would it be worth it? Now, in 2001, which was a long time ago, I got my first CCIE, and in doing so, it was not easy. I studied probably 8 months, and I think it was 4 or 5 hours, 4 or 5 days a week after work, studying, like just raw study practice. And I would have people that were not always hoping I was going to do it. I had a lot of people that didn't want me to do it. Loved ones, like, oh, you worked hard enough. And so the kids would go to bed, and I would go into this room, this dining room or side room, and I would just work and study. And I had a lot of feedback that said, oh, you've done enough, you can stop. And secret is, I really wanted it. I had several children. 2001, I have 7 kids. Most of them are grown. My youngest is 16. She'll be 16 in December of 2019. But all the rest are 21 or older, and they're all amazing. So I had a lot of motivation for me. It's like at that time, I needed to make enough money to provide for my family. And I didn't have I had a high school education, but I didn't have a college education. I went for 1 semester, community college. That was it. And then I wanted to go out in the world and, make my mark. And I realized that there's no free lunch. And so I had an opportunity to start I was a cashier. And I saw this guy coming in to fix the cash registers with this silver briefcase. And wow, I'm going to get emotional. Anyway, I saw him. He had a good car, a decent car. I thought it was a decent car. And it looked like he had a good job. And I saw this advertisement on the TV that same week for Control Data Institute. Get a job in the world of IT. And I thought, this is 1984. And I thought, you know what? I can do that. I need to make a change. So back in the 80s, I paid like or $6,000, got a loan, and went to this technical school, studied super hard, and then got a job with EDS. Right, actually, they took me out of school early because they needed somebody, and they were impressed by my eagerness and my willingness to learn. So I have YouTube videos on all that. I won't repeat that here. My journey through the world of EDS and my first job and my CCIE exams, and those are all very fun for me. The stories are very, very fun. But at that time, it was worth it. So 2001, or up to that point, I was not desperate, but I thought I need to provide for my family. They need, I'm it. I'm the end of the road. All these children and my wife, they need me. And so part of it was a little bit of desperation, but I enjoyed it, and I pushed hard, and I got my first CCIE in 2001. And then I went for another one in 2003 in security. And ever since then, I've continued to study and learn. Now people ask me, well, are you going to go for another CCIE, like in data center or something else? And that's the question I ask myself now is, what do I need to get? Do I need that, or do I need the skills, or where would my time best be applied? That's the real question at my age. And I'm focused on the 20%. This is the core of the matter. I'm focused on the 20% of what I can do as a human being to help other people. That's it. It's like, what's the most I can do with the most impact, with the most specific effort to help as many people. And one of those things is YouTube, because I'm reaching a lot of people, which is fantastic. I want to help you with your goals, what you want to achieve. And also CBT Nuggets has been incredible for me, because it gave me a space where I can create content that I care about, that matters to people, and they give me a lot of room to create that content, and I just love it. So going forward, if the CCIE is important for you, if it's important financially for you, or for self-esteem, or for cred among your peers, or just to get the skills, I would say getting the skills and the knowledge would be the biggest thing, the most important thing. And the certification, if you want to choose to prove it or demonstrate it to the world, would be a secondary thing. So that is... Keith, get off the soapbox. Okay, I'll get off. It depends, I guess, is the answer to that. Okay, and last question, is Dora unicast or broadcast? Great question. Dora referring back to our topic of DHCP, Discover, Offer, Request, Acknowledgement. And the answer is, it depends. The first Discover message from the client, if we're a DHCP client, it is always, if it's a brand new client, never had an IP address before, doesn't know who the DHCP server is, it's always going to be broadcast. But after that, there's some dependencies based on the flag in that Discover message. So in the DHCP messages, there's a flag for broadcast or not, and based on how that flag is set, some of these subsequent frames may not be broadcast. Because think of it, if we send a broadcast and there's a DHCP server, it knows our source MAC address, it saw it. It would have the ability technically to respond directly to our layer 2 address. So the way that most people teach it, which is good to know, most people teach it, it's all broadcast. And here's why. DHCP Discover, broadcast for the offer, so that if other devices or servers see it, they can know about it, and then the request. So it's possible that all four could be broadcast, but literally, with the protocol analyzer and modifying that broadcast flag, it's not always, all the frames, the first frame is always a broadcast, but all the rest are not always a broadcast. Now that is way beyond what a CCNA student would be required to know about. But it's the fun stuff that by working with products longer and discovering how they work, where you can really dig in and say, and yeah, it's a great question. I love studying. I do. Okay. All right. I think I've taken all the time that I deserve. I'm grateful for our time together. Our topic next week, based on popular vote, is going to be dynamic ARP inspection. So I look forward to streaming that next week. If I plan on going through almost all the skills that I've created at CBT Nuggets. And then when those are done, I'm also thinking about doing something called Sunday subnetting. making a small series, a live stream, doing it on Sundays for like half hour for a few Sundays on IP subnetting. I think that would be fun. I've gotten a lot better than that over the last 20 or 30 years, and I enjoy sharing that with people. So just checking for any last questions here. I do want to thank everybody for showing up and participating in the live stream. I also want to thank Jake from CBT Nuggets for being so diligent in helping me with managing the queue. And that's it. So if you haven't yet subscribed, please take a moment to do so today. If you are anticipating a CCNA journey, please join me here. I've got a lot of content on this channel that tries to cut through the noise and shares with you exactly what's important about the technology for CCNA. And I do believe that getting a CCNA certification to demonstrate your skills, which is the most important part, is a important step in the world of getting skills and making a difference and becoming more valuable to everybody in your circle. So thanks for joining me. I'm going to put on some exit music, and I look forward to seeing everybody either in the stream next week or in a subsequent video. Thanks, everybody.